Welcome, grade 12 Mindsetters. Finally, it's your chance. If you've been watching since grade 10, which I hope that you all have been, this should be your third hour in and you've been having a fantastic time. Liesel's taking us today. She's going to be chatting about finance.
Yes, guys, what we're going to be doing is we're going to start off by just revising some of the finance that you did in grade 11. So we're going to be looking at the simple and the compound interest formula, which is actually from grade 10, come to think of it. Then we're going to go a little bit further and we're going to look at how to solve some things that are ever so slightly more tricky. Bound to be a lot of fun and a good basis for your finance, which is going to go forth from here.
Fantastic. So you guys all better be joining in. Join us on Facebook and Twitter. And we just want to say a big thank you to Liberty for sponsoring the show. You guys are fantastic. This lovely set. So yeah, let's take a break and we'll be back with you shortly. See you now. Welcome back, grade 12. So happy that you're joining us. I know that all of you wait for this session. I know whenever we start grade 12, the page just explodes. So this is a quick hello from all of us here at Mindset Learn to you guys sitting there on your couches at home, and we hope you guys are tuning in. So I want to say a quick hello to Mika. You're watching. I hope you're having a great day, Mika, and I hope you enjoy the show. Let's get straight to it. Liesel, take it away.
Right, guys, so the start of today's lesson is a little bit of a blast from the past. We're going to have a look at the simple interest formula, also at the compound interest formula, but then we're going to move on to some slightly more difficult things that we wouldn't have necessarily been able to do in grade 11. Right, so I've got our simple interest formula on the board here for us. We've got A equal to P bracket 1 plus I times N. So let's just talk quickly about what everything stands for. A is our end amount. So if you are investing money, A is the amount that you will receive at the end. P is our principal or our initial amount. So that would be the amount of money that goes into the bank at the start of your whole savings venture. I is our interest rate, guys. And remember that interest rate by definition is out of 100. So if I say to you 10%, you don't put 10% into the formula. You remember that 10% is 10 out of 100 and therefore you write it as 0,10. N stands for our time period, and we know that we're going to be calculating N whenever we see the words how long. Okay. So let's have a look at our first example. It's a relatively simple one. We didn't make a story about it. I just gave you the information as it is. Right, so our end amount is 1,000 Rand. So in the end, after our investment, we end up with 1,000 Rand. Initially, we invested 500 Rand. Our interest rate is 12%. And if the question had a story attached to it, it would have said something along the lines of simple interest. Because remember, guys, we have to clue you in as to which formula you have to use. So the story would have said simple interest, and let's have a look at how we would approach it. There is our formula, and the first thing I'm going to do is just substitute into my formula. Well, a pen would be good. Substitute into the formula. Now, as you guys can see, my unknown over here is N. If there was a story attached to this particular question, I would have said something like, well, let's think of a story. Let's say that Indiana invests 500 Rand at 12% per annum, simple interest. She gets 1,000 Rand at the end of her investment. How long did this take? That would be a perfectly legitimate story. Let's have a look at substituting in our information. So remember, guys, units only need to be put in the end, so I'm not going to put the Rand sign in at the moment. I'm going to say 1,000 is equal to my initial amount, which is 500, and then open my bracket, 1 plus, and now my interest rate is 12% per annum, simple interest, but remember that would be 0,12, and that is multiplied by N. I don't know why I always manage to do this, but I always run out of space in the end. Right, so in this case, it's not difficult to solve for n because n is in the linear. So what I mean by that is n is in the same straight line as all of my other amounts. Obviously, you guys will know that it gets a little bit more complicated when I'm using the compound interest formula because then, of course, n is in the exponent. Now, there's various different ways that you can go about solving this. I would probably start by dividing both sides by 500. So I will do that. And 1,000 divided by 500 obviously is 2. So now I have got on this side 1 plus 0,12n. I'm going to take the 1 over to the other side and subtract it. I hope you guys are still following. So then I have got 0,12n is equal to, and on this side I have 1. And of course now I need to divide by 0,12 on both sides. So let's bring up our calculator. And I'm going to say 1 divided by 0.12 equals, and that would be, my answer is 8,3. Now remember, when we're dealing with simple interest, we're always working in years. So that means that this interest rate, if it's simple interest, it's going to take a whole 8 years to double your money, which is not the greatest because your money probably won't be worth that much after that. But guys, a very, very simple example of calculating n in a simple interest context. Now, we're going to have a look at when things get a little bit more complicated, and we're going to move on to compound interest. Right, guys, now what I'm going to do is I'm going to have a look at the very same question using the same amounts, but this time in a compound interest context. So our compound interest formula, of course, is A is equal to P, 1 plus I to the power n. So now our n is in the exponent, which is going to make things slightly more complicated. Now, once again, I'm going to put a context to this question. I'm going to say, well, now, let's say Mika invests 500 Rand at 12% per annum, compound interest, so that's per annum. In the end, she receives 1,000 Rand. How long was Mika's money invested for? Right, now, we're going to see that things now get ever so slightly more complicated. I'm going to start off by just substituting into the formula. Right, so again, I'm going to say 1,000. Again, a pen would be good. 1,000 is equal to 500. My interest, remember that it's as a decimal, so that's 1 plus 0,12, that's 12%. And my unknown n is now in the exponent. Okay. So once again, I'm going to do a little bit of work, just manipulate this expression a little bit so that I at least have the same things on the same side. So similar to what I did just now, let's divide by 500 on both sides. And in fact, boys and girls, a bit of a warning here. This is something that I sometimes see at school or when I'm marking matric papers, and maths teachers find it very, very upsetting. Guys, whatever you do, do not multiply this 500 into the bracket, because that bracket is to the power n. You cannot now multiply that 500 into the bracket because the 500 was never to the power n to start with. So please, guys, don't do that. We'll divide both sides. That'll be much better. So I get a 2 over here. And then, of course, my 500s cancel. Inside my bracket, I can add the 1 to the 0,12. So that gives me 1,12 to the power n. Now, this is the point, boys and girls, where we need a little bit more knowledge than we had in grade 11 in order to solve this. In grade 11, you would have used a method called trial and error, or some teachers call it trial and improvement. And you would have kept on substituting different values for n until you got as close as possible to 2. So that's what we would call trial and error. You'd start with 1, then you'd maybe try 1,2, 1,4, until you got relatively close to 2, and then you could say, all right, now that's the end of the story. However, in grade 12, we will expect of you a more accurate answer. And this is where our log laws come into play for the first time. Now let's just scroll down over here. Let's have a look at this example 3. If I said to you in grade 11 or even in grade 9, 2 to the x is equal to 8, you would have said to me, well, this is not a problem at all. What I need to do is I need to get my bases the same on either side. So I would say 2 to the power x is equal to 2 to the power 3. Now, because my bases on either side is a 2, it is now possible for me to cancel out the bases. Let's color them in there. And then to say, okay, x is therefore equal to 3. So that's fine. But let's have a look at the example on the right-hand side, because that poses a bit more of a problem. 2 to the power x is equal to 7. Now, I cannot use the same method that I used on that side because I do not know what power of 2 will give me 7, and it definitely won't be an exact number. And this is why we are taught our log laws, and that's really the main reason why we learn logarithmic manipulations, is so that we can know the third log law. Now, the third log law says to us, if I have the logarithm of any number to the power x, like that, I can do the following operation with no consequence. I can say that is equal to, now I can take that x and I can bring it to the front. So on your calculator, it will be exactly equivalent if I write this as x log a. So that's a little trick. Some teachers even teach you guys how to do this in grade 11 already, so that you can avoid all of that trial and improvement. So for instance, if I have log of 2, or let's rather do it this way, wait a minute. If I have log of 8, I'm allowed to say that the log of 8 is the same as the log of 2 to the power 3, because of course 2 to the power 3 is equal to 8, and I am then allowed to write it as 3 log 2. Okay, so this is the only, this log law is going to help us to solve for n in our compound interest formula. But just quickly, let's have a look then how I'm going to use logs to solve this particular one. Let's just rub out all of our writing. Okay, so what you guys should know by now is in an equation, as long as I do the same thing to every term in the equation, I am not changing the integrity of the equation. So what I'm going to do over here is I'm going to introduce a log on the left-hand side. Okay? Now, if I did it only on the left-hand side, that would be problematic, right? So I also have to put in a log on the right-hand side. Okay, so that's log 7. Let's just write it like that, to preserve the integrity of the equation. Now, as I showed you guys before, I am now allowed to do the following. Ka-ching, put the x in front, and I get x log 2 is equal to log 7. Right? So I haven't changed anything about my equation. Everything is still even Steven on both sides. Now I'm going to isolate the x. So I'm going to say x is equal to log 7 over log 2. Right, so let's bring up our calculator. Clear it there, oops. all I wanted to do was clear it. Now it seems to, there we go. Right, so I'm going to say log 7 over log 2, log 7, close my bracket, move downstairs, log 2, close that bracket, equals. And that the answer that I get is 2, 8. Now, to me, that actually makes perfect sense, because if you guys think about my original question that said 2 to the power x is equal to 7, if I said that x is 2, then my left-hand side of my equation is 2 to the power 2, which is 4, which is not even close to 7, right? The next integer that I could have used would have been 3, so then 2 to the power 3 is equal to 8. That's a little bit more than what I need, but it's closer. So therefore, that answer of 2 to the power 8 makes perfect sense to me. So guys, let's get back to our actual example over here before I started scribbling all over the show. So once you know the trick, it shouldn't be too much of a trauma. I am now going to take another color pen. Why not? Let's take pink. It's my favorite. Put a log on the left-hand side. Put a log on the right-hand side. Then I'm going to use the third log law, which says as long as there's a log, I'm allowed to bring that exponent to the front. So this right-hand side becomes n log 1, 1, 2, and log 2 on this side. And now, in order to get n on its own, I'm going to divide both sides by log 1, 1, 2. Of course, guys, you don't have to show as many steps as I am. I'm just making sure that I don't get problems from Indiana because our students are not understanding. Right, so back to our calculator. We'll clear it. Fraction jobby. And we're going to say log of 2. Close the bracket, divided by log of 1, Indiana, I hate it when that happens, 1, 1, 2, close the bracket again, and our answer is 6, 1, 1. So, if you guys just think again about the context of the question, the first example that I used simple interest, right, and it took more than 8 years for the money to double. In the second example, I used compound interest. It was still 12%, and now the time needed to double the money has actually come down to 6 years. So definitely, if you are investing, it looks like compound interest would be your best bet. So here's my question, guys. Bongani invests 750 Rand at an interest rate of 12% per annum, compounded quarterly. How long will it take for his investment to double? There's a lot of doubling of investments going on in tonight's lesson. Right. So there's a couple of things that we need to think about in this question. Firstly, we are talking about compound interest, so we're going to be using the compound interest formula. So that's the first thing that I'm going to write down is my compound interest formula. A is equal to P 1 plus I to the power n. Now, for the first time in tonight's show, and I perhaps need to remind you guys of this, we have a different compounding period than a year. Now, they say specifically that our interest is compounded quarterly. Now, what does that mean? It means that instead of waiting until the end of a year before you get your interest, you get a portion of that interest every quarter. So that would be 4 times a year. Now, just quickly, let's run through that again. If I say quarterly, what I need to do is take my interest and divide it by 4. If I say bi or semi-annually, that means twice a year. So bi or semi, my interest is divided by 2. Then the other common ones that we do get is daily. Now, if we say that our interest is compounded daily, we assume that a year has got 365 days. So therefore, daily would be my interest rate divided by 365. So that means you get a minuscule portion of your interest every single day. And I think the other common one that we often use is, the other one that we commonly use, I think, is monthly. So let's put that one in. Well, I think you guys should be able to remember it. And anyway, I've run out of space. So quarterly divide by 4, bi or semi-annually divide by 2, daily divide by 365, and monthly divide by 12. Right. Now, there's something very important that we have to remember whenever we are dealing with a compounding period which is not yearly. Okay? If I make my interest quarterly, then I'm taking my interest rate and I'm dividing it by 4. But then I would have to multiply my n by 4. So very important that my interest rate and my time periods always have to match up. So in this particular question, I need to remember that the answer that I get is no longer in years because I'm working in quarters. It is now in quarters of years. So if I get an answer of 8, that doesn't mean 8 years. It means 8 quarters, which is actually 2 years. So we just need to bear that in mind. Right, so let's substitute in our information. If Bongani is doubling his investment, what is going to happen is 750 Rand doubled. That shouldn't be too hard. That's not enough to win the prize, Indiana. 1,500 Rand over there. Right. His principal or initial amount is 750 Rand. Right, into my bracket, 1 plus, now my interest rate as a decimal, lots of 12s going on here, but it has to be divided by 4. Everything to the power n. Right. So far, so good. Now, Musa, I hope you're watching because, again, please note that I'm now going to divide both sides by 750. I cannot multiply 750 into that bracket because 750 is not to the power n, so that just won't be cool. Divide by 750 both sides, I get a 2 on my left-hand side. And for those of you that love using your calculators, let's do it. Let's clear that. And we're going to say 1 plus fraction 0.12 divided by 4. And our answer is 1,03, which of course you should know, but I just like to show off that I can use the calculator. Right, so that's equal to 1,03 to the power n. And now, of course, comes the part where I have to do my little trick. And even if you're in grade 11 and you're watching, it's maybe just nice to know next year you're going to learn about logarithms. And the trick is always with equations. Remember, whatever I do on the left, I also have to do on the right. So everything has to be treated equally. I'm going to put a log in over there and a log in over there. Right, I'm running out of space. If I then take that in and I move it to the front, and if I take that in and I move it to the front, sorry, oh my goodness, trying to make my page longer, but that's not really working here. It's not. Okay. Guys, we've got a gremlin.
Oh no.
Indiana? Okay, there we go.
There you go.
There we go, there we go, there
I was
we
about
go.
to take
Okay.
you to a break, but not
Right,
to worry.
no, not to worry. Right, guys, so now if I take the n to the front and I divide both sides by log 1,03, I'm going to get my answer. So let's have a look. I'll use a different color. I'm going to say n is equal to, so now the n is in front there, log 2 over log 1,03. Now some of you are probably thinking, But why aren't I using another function on my calculator, guys? You can do this. Let me just show you. If you use this function on your calculator, that one, it has exactly the same effect. So I can put the bottom one, the 1,03 in there, and then I can move across and put the 2 over there. It comes down to the same thing. And my answer is 23,4497. Now, guys, if this was years, and I have to wait 23 years to double 750 Rand, well, I don't even want to tell you how old I'm going to be, but I'll definitely be using a walking stick. So, this is not years, this is quarters. So, it'll take 23, some change quarters for Bongani to double his money. So, now I'm going to divide by 4. If it makes it easier for you, you can actually replace that n with a 4n if it's quarterly, or a 2n if it's biannually, and so forth. But I like to just remember, so let's go divide by 4.
Liesl, I think a lot of mindsets is when you said quarters, I think they went, oh.
I think it's just that old perception about fractions. Fractions are just ordinary numbers, and we really need to stop discriminating against them. Right, so there we go. Divide by 4, and that actually takes 5,86 years. So that is pretty close to 6 years, but that's a lot better than 23 years, of course.